I am Dr. Abraham Varghese. I welcome you all to my YouTube channel, Learn and Practice My Class. Today I am going to take Business Statistics for MBA, and the portion I am going to cover is definition, importance of statistics, statistical data, source and type, classification of data, frequency distribution, diagrammatic and graphical distribution, histogram, frequency polygon, cumulative frequency curves, and ogives. First is the classification of data. First, what is data? Data means any bit of information we collect for further analysis to get more information or to take a decision. There are three ways of data collection. One is called response, second is observation, and third is measurement. Response means the researcher asks the information from people who are directly involved in that particular task. And if I want to analyze about market trend, I have to collect information from either retailers or maybe marketing executives. So they are respondents. And I will collect data either interview method or maybe using a questionnaire. And the data we collect from them, we will tabulate it, analyze it, and make more information for further decision making. That is called response. In observation, the researcher will observe the phenomena and record the observations. For example, a person who is analyzing stock market, he collected the information of the stock performance of different companies or as a whole for a specific period and identify which are the firms and which are the sectors perform very well, which are the sectors are not performing, and these are called observations, and he will note the reasons or maybe what are the points he is observing from the market. That's called observation. And measurement means they will conduct an experiment or maybe some phenomena is naturally happening, and from that I collect the data, note down the data. That is called a measurement. For example, a nurse is collecting information on the health condition of a patient, maybe temperature, maybe BP, or maybe some other information that can be observed directly, maybe this echocardiograph, anything. So these are examples for three types of data, and in that it is further divided into two types. One is called quantitative data and quantitative data. Quantitative data means any data based on a quality, and the other is quantity. Quantity means it is a measured. And qualitative data is further divided into nominal data and ordinal data. But quantitative data has only one subclassification as scale data. It is further divided into discrete data and continuous data. Next question is why we have to study business statistics. Business statistics is an important part of business management to analyze the economical dynamism in the market to take the appropriate decision. They have to collect the information either by observing or maybe from the response or direct measurement, and then they organize, analyze, and interpret data. Now, I already told about the quality means it is some attributes, and one attribute here we have taken is color. A and B are two products. One is red and the other is blue. So it is blue. So we can differentiate A and B based on their color. It is a quality. So next one is P is lighter than Q. That means color of P, red color of P is lighter than Q. That means A person is entering a textile shop and he wants a red cloth. The salesman is showing different clothes and he differentiate. Okay, P is lighter than Q. So it is called qualitative. We are only quality, we are not measuring. Another example, one snake is lengthy, long one. It is a long one. Long means we have not defined any quantity for it. If you are not defining, only long I am telling, it is an attribute, it is a quality. If I measure the length of the snake using a tape and say 2 meters, it becomes quantitative because quantified. Quantified means when we represent any attribute by a number as its measurement, then it becomes quantified or quantitative. Ordinal data and nominal data. Ordinal data means any data that can be arranged in an order. Generally, this data is used for subjective attribute measurements like satisfaction or happiness, etc. And here the general scales we are using, generally it is called Likert scale. Highly satisfied, satisfied, neutral, unsatisfied, and highly unsatisfied. And the numbers are attribute 5, 4, 3, 2, 1. And this an order is there. That's why it is called ordinal. And again, nominal data means any data that can be classified, categorized based on attribute. For example, gender, male and female. So it is a categorized data, or we can say it is called nominal data. And scale data means any data that can be measured by a number and that number represents it. Then it is called a scale data. Next one is called discrete data and continuous data. Discrete data means any item that can be counted, identified by physical appearance. Then it is called discrete. We can identify and recognize it. Then it is discrete. Otherwise it is called a continuous. For example, water is pouring from a tap, and if you can identify one drop out of it, is very difficult because water is flowing continuously. So when we are not able to one basic element from a group of data, then it is called we cannot identify a basic group. Then it is called a continuous data. So there are two types of presentation of data. One is called tabular method and the other one is called graphical method. It is the tabular method. In this case, we have taken 5 schools and more than 1,200 students have taken. Instead of putting this table, if full numbers of this case is mark of a mathematics subject. So instead of putting like this table, I write more than 1,200 numbers and give to your hand. Why? What do you understand? Nobody will understand. It does not have any meaning. So to give a meaning, to understand the information properly and to inform more idea from the data, we have to represent the data in such a way that it will be convenient, expressive and relevant. So in this case, the total data is divided into 5 schools and we know the number of students from each school, what is the average, this analyzed, and we know what is the percentage, and again we have how many percent of students have more than 75%. So it gives a complete analysis of the result so that we can compare the performance of the students of these 5 schools. This is the benefit of the tabulation of data. Now, one-dimensional and two-dimensional. One-dimensional means, for example, if I go to one school, one class I have taken, then 60 students are there. Then I ask mark for mathematics from these 60 students. Then it is one dimension because only one item is measured, one dimension. As in the previous table, we have one measure is schools, the other is mark. It is two dimensional. And now this is called heterogeneous and homogeneous data. All the students studying in a school, all having the same identity card. Then it is homogeneous because all belong to the same community and the school name is common for all students. So it is homogeneity. And if I categorize based on the class, so they will be classified into different groups and it become heterogeneous. So homogeneous means any attribute that is common to all members of the group, it is called homogeneity. And anything that varies from one group, a subgroup to another, then it becomes heterogeneity. So the tabulation of data again depends on the type of data, whether it is scale data, means qualitative and quantitative. In that itself, nominal data or ordinal data. So in the next two slides, I am going to explain the difference between these two. This is a qualitative data. In this data, it is a nominal data because five different colors of balls are there, 4 colors are there: blue, red, white and yellow. It is mixed together, and any person who wants to classify, so he bring all red together in one bag, yellow together in another bag, red in another bag, white in another bag. So it is segregated. So blue is 13, yellow is 14, red is 13 and white is 10. It is a nominal data and it is again a quantitative data because the balls are classified based on the color, that is an attribute. Then satisfaction level 5, 4, 3, 2, 1. 5 is highly satisfied, 4 is satisfied, 3 is neutral, 2 is unsatisfied and 1 is highly unsatisfied. And now when we classify it into a table, then so 5 here, 2, 4, 14, 3, 18. So you can see that one sign slash. Now this is called tally. So it is also for example in the previous question when we take 5. So first is 1. So I go to the column of 1, then I put a slash mark. Then next I will go to 2. Then I go to row of 2 and again put slash mark. So it will be convenient without making any missing. We can arrange or mark all the numbers and then we count it and we can convert it in this raw data into a tabulated data, and this mark is called tally mark. And when we add all these frequencies, we have to find out the total number of elements in the group. So this is another data. It is a nominal data because it is based on age, but at the same time it is a scale data because we are measuring age of a group of people more than 90. So it is an age. So this is a measured or maybe the scale data. So now this how we have to decide the class and number of classes and class width. Now here you can see that if 90 elements, 90 data are there. If I take all these data together, we cannot understand anything. For example, if I want to analyze the effect of diabetes or maybe probability of diabetes spread among the respondents, there is one study I am going to conduct it. If I get all these 90 together of all the ages together, I cannot identify anything. So what I do is, so first is only one class full 90 people together, and I divided into 2, 0 to 45 and 46 to 90. So now I can understand what is the possibility for diabetes in the age group of 0 to 45, and what is the possibility for diabetes in the age group of 46 to 90. And third one, so again I divided 0 to 30, 31 to 60, 61 to 90. So 0 to 30 means it is earlier in age, middle age, and senior citizen age. So what is the chance of the diabetics, we can understand. In the fourth one, we take 0 to 22, 23 to 45, 45 to 66. And as the number of classes increases, class width is decreasing, and the more the information we can explain out of it. So as a thumb rule, we can say narrow the class, more the accuracy, lower the class, more the number of classes, and complexity of analysis also increases, and it is better to keep the class width the same everywhere, and it is a must to go for compromise that the class width and the number of classes. And if I explain this as a pictorial format, only one class, class 1, class 2, 3 classes means as the number of classes increases, class width keep on decreasing. And this is again another, blue stands for the number of classes, and red stands for the class width. Now that age is again made into tabulation, and this is the tabular form. 10 to 99 people are there, 20 to 29, 37, total 90 respondents are there in this survey. Now next is how to represent this data, diagrammatic or graphical method. Why we need? If you are making any presentation to your boss or maybe your set of customers, at the time if you give the tabular data, it is very difficult to explain and even convince. So in that cases, visual presentation will be more important. So here I am telling about 4 types of graphs. One is called histogram, pie chart, frequency. These are examples only I am telling. This is some examples. One is called bar graph, and again histogram, then pie chart. The first one, bar chart. Usually bar charts are used for the heterogeneous data, mutually exclusive data. That means, for example, if you are analyzing the literacy level of 4 states, the literacy level of 4 states are mutually exclusive. The mutually exclusive means what? The information of one is not depending on the other in any way. That's called mutually exclusive. So such information can be explained in graphical form using the bar chart. And it is helpful to understand the visual comparison. And now this is an example. We have 6 brands of cars are sold in a particular city. So that is shown as a bar diagram. So the sale of Toyota is not depending on Honda. So they are all mutually exclusive. That's why there's a gap between all the bars. Now, how to make a bar chart? So we have got 250, 214, 235. The actual sales are there. First step, what we have to do is to fix the width of the bar. Here I have taken a scale. Scale is 1 centimeter equal to 25 units or 25 cards. So now I have to understand. So 1 centimeter means 25 cards. Then how many heights will be there? That means the area of that bar represents a shape. These are all rectangular shape. Area of the rectangle is length into breadth. So if we fix the breadth, we can automatically calculate the height or length. So here we can see height and width will be more easy. So width is fixed 25. 1 centimeter equal to 25. That means how many centimeter height should be there? 25 divided by 250 divided by 25. 10 will be the height. So like that we can. So here width is fixed. So that we can calculate the height. So histogram generally is used for the homogeneous data as we used in the previous age. So 90 students is one group of people, and for the convenience I have made into 0 to 9, 9 to 10 and all. So it is a sub classification. In that case histogram is very important. Because of that, the bars between two different bars in the histogram is not separated as in the bar chart. It will be all together. Only maybe a line will be different because it is said all together represents the full population. So you can see here it is as a one block, but only the height is differing because each graph is a part of a big data. So maybe we can say subset we can say. And the height of the graph represents the frequency. Now next is frequency polygon. Frequency polygon, to make frequency polygon, what we do is to mark the midpoint. So every point means turning point on the frequency polygon, the coordinates will be given as a midpoint of the width will be x and y will be the frequency. So this is the graph. Then cumulative frequency curves. So far we have taken the frequency directly. Now we are going to take the cumulative frequency. So this is cumulative frequency. Our class was starting from 9. Then next is we start from 0 to 9, 9 to 37, 46, 46 plus 8, 54, 54 plus 12, 66, 66 plus 12, 78, 78 plus 7, 85, 85 plus 2, 87, 87 plus 3, 90. So it is in the, so we are going to explain less than OG. That means we can see the cumulative frequency in the ascending order. And what's the meaning of less than OG? For example, if I take a particular point here, this is one point, and all these previous points are less than this particular point. So all is less than. So this less than OG. So more than OG or greater than OG. So when we take this, one more thing I have to explain here. When we this less than OG, you can see that this line graph is starting from 0. Starting from 0. And you know that the original number, here you can see here. You can see that 10 to 15. It is the starting and ending is 80 to 90. That is original. And when we started here, it is starting from 0. Starting from 0. For that, we have added one more class here. Actually, it is a dummy because it does not have any frequency. So when we add this 0, this graph will be starting from the x-axis. In the same way, this is more than OG. More than OG means you take any point of here. This point is greater than the remaining portion. So here we can say this, it will be this portion is high. Now when we combine both together, so now both have taken together, this is more more than OG, and this is less than OG, and this is meeting in this point, and when we make it here, so this median class is coming in the 30 to 39, and the approximate frequency is 50. Okay, so this is called this point is called median. So center point is called median. And why we are using it means if you are using little more information, for example, if you are using quartile in that one, at the time we can further classify into 75%, 25%, and 50%. 50% stand for the median, and 75% will be the upper quartile, and 25% will be lower quartile. So this the three the concepts of the data description, and two more important data has to there about relevance, accuracy, and validity. If the data is not accurate, the results also will not be accurate. So accuracy is very important. Second is relevance. Relevance means, for example, if I want to analyze economic activity in Karnataka, if I use an information from Andhra Pradesh, will not work, because data from Andhra is not relevant to Karnataka. So relevant means how the data is linked or associated. That is very, very important. So relevance is very important. Validity. Validity means no COVID season is going on, second wave is going on. Last year during the first wave also economic slowdown was there, a lockdown was there. During that period, what was the economic activity? We have got some data. This year also, during the lockdown, some data is there. So that data is valid for that period, and this data is valid for this period. I cannot substitute that data for second wave, and second wave data cannot be used for first wave. So what are the information we are measuring during this wave period, second wave period, that is valid only for this period. So that is validity. How long a data is valid, existing, true, that is called validity. Now I request all of you to view this channel continuously, and again press the bell button so that you will get all the latest videos I am uploading, and also subscribe. Secondly, along with every YouTube video, I will be adding one exercise and one registration form also will be there. I request all of you to fill the registration form and send to me, and in addition to that, try to work out the questions given. If you are not working out the question, this effort is waste. So it is a need. Then in statistics, unless you don't practice, you cannot understand the concept. So thank you so much.